Welcome to the deep dive. Today we're tackling something really interesting, fine-tuning generative AI.
Yeah, it's a hot topic.
It is. Think of it like taking these already powerful AI models and, tailoring them, making them perfect for what you specifically need.
Exactly.
And we really want to focus on how to make this whole process quicker, maybe easier, especially for cool stuff like, say, generating 3D avatars.
Right. And we know you, the learner, want the key insights without getting totally swamped in technical jargon. That's the goal here.
Definitely. A shortcut to understanding this.
We've looked at quite a bit. Forum discussions on image generation, technical docs, what people are actually doing with avatar tools that we've tried to pull out what really matters.
Okay, let's jump in. What is fine-tuning, really? When we talk about AI models, is it like extra school for the AI?
Huh. That's not a bad way to think about it. Imagine you've got this base model, like a pre-made suit. It's good, but maybe not a perfect fit. Fine-tuning is like tailoring that suit. You make specific adjustments based on, say, your measurements, or in AI terms, your specific data, so it fits perfectly for a particular job.
Gotcha. So how is that different from just writing a really good prompt? Prompt engineering is huge, right?
It is, and it's useful. But fine-tuning is, well, deeper. Prompting and few-shot learning, showing the model just a couple of examples, it's like giving instructions.
Right.
Fine-tuning is more like actual training. You show the model many more examples, maybe thousands, focused on one task. And this actually changes the model's internal wiring, its weights.
Ah, okay. So you're actually modifying the model itself, not just guiding it for one output.
Precisely. And that leads to some real advantages.
Like what?
Yeah.
Why go to the trouble? Is it worth it compared to just getting better at prompts?
Well, often, yeah. First, you usually get much higher quality results for your specific task. The model just gets better.
Okay.
You can also train it on way more data than you could ever cram into a prompt. Think about that.
Yeah, that makes sense.
Plus, sometimes, once it's fine-tuned, you can use simpler, shorter prompts, which can actually save on tokens, so save money,
Oh, interesting. Token savings.
and potentially lower latency to faster responses. So, several good reasons.
Definitely sounds compelling. Now, I bumped into this term, LoRa, L-O-R-A, low-rank adaptation. Sounds very technical.
It does, but the idea behind it is actually pretty clever and practical.
Okay, break it down for us.
So, imagine these huge AI models have billions of parameters, like tiny adjustment knobs. Fine-tuning all of them takes massive computing power and time.
Right, expensive.
Exactly. LoRa is a technique that says, hey, maybe we don't need to adjust all billion knobs. What if we only focus on a small, strategically chosen subset of them? It identifies these sort of high-impact parameters.
Like finding the master controls?
Kind of. It adds small, low-rank matrices alongside the original weights and only trains those. It's much, much less computationally intensive.
Ah, so it makes fine-tuning faster and cheaper.
Bingo. It drastically reduces the resources needed, making fine-tuning accessible even if you don't have, a giant server farm.
Oh.
It's a big deal for democratizing this kind of customization.
Okay, LoRa, faster, cheaper fine-tuning. Got it. So if someone listening wants to try this, are there platforms or tools that make it, well, less daunting?
Yeah, absolutely. Things are definitely moving in that direction. One major platform offering this is the Azure OpenAI service.
Azure OpenAI. Okay, what models can you fine-tune there?
They support quite a few different versions of GPT-35 Turbo. The newer GPT-4 the one from August 6th, 2024 specifically.
The really new one.
Yeah, and its mini version, GPT-4 Mini, from July 18th, 2024. Also some GPT 4.1 models from April 2024. And interestingly, you can even fine-tune a model that you've already fine-tuned.
Oh, so you can keep refining it, like layering the training.
Exactly. Continuous improvement. It's pretty powerful if you want to keep adapting your model as you get more data or refine your needs.
Cool. So practically, how does it work on Azure? If I wanted to fine-tune, say, for generating specific avatar descriptions.
They've got this portal, the Azure AI Foundry. The workflow is fairly straightforward. First, you need to prep your data.
The training examples.
Right. Training data and ideally some validation data too, just to check how well it's learning on stuff it hasn't seen during training.
Okay.
Then you pick your base model, like GPT-35 Turbo or GPT-4o. You upload your data files. You can adjust some training settings, the hyperparameters, or just stick with the defaults.
Hyperparameters. Those are the training settings, like learning rate.
Yeah, things like learning rate, number of training cycles, batch size. You tweak those, then you review your choices and kick off the training job.
Okay, data prep sounds critical. What format does Azure need? Is it just plain text?
No, it's specific. It needs to be in JSON lines format, JSON.
JSON, okay.
Each line in the file is a separate JSON object representing one training example.
Hmm.
And crucially, it needs to follow the conversational format that their chat completions API uses.
Conversational format, what does that look like?
So each JSON object, each line, has a key called messages. And the value for messages is a list.
A list of turns in the chat.
Exactly. Each item in the list is one turn with a role, which could be sys for initial instructions, user for the input, or assistant for the desired output, and then the actual content of that message.
Okay, so like system says you are an avatar bot, user says create a sci-fi avatar, assistant provides the description.
Precisely. You structure your examples like that.
Yeah.
And it supports multiple turns in one example, so you can train on longer conversations. And importantly for avatars, it supports vision tasks too. You can include image URLs in the content.
Whoa, okay, so you could actually show it pictures.
Yeah, like user, describe this style of avatar, and then provide an image URL followed by the assistant with the correct description you want it to learn.
That's huge for visual stuff. How do you get the data file in there?
Couple ways. For smaller files, you can just upload directly in the portal. If you've got a really big data set, they recommend using Azure Blob storage. It's more robust for large transfers.
Right, and once it's training, can you see what's going on, or do you just wait?
No, you can monitor it. There's a fine-tuning page in the portal showing the progress.
Yeah.
And as it trains, it creates checkpoints.
Checkpoints, like saved versions.
Yeah, basically functional snapshots of the model at the end of each training cycle, or epoch. Once it's done, you usually get access to the last 3 checkpoints.
Handy if one performs better than another. How do you know if it is performing better? How do you measure success?
After training, you get a results.csv file. It contains metrics like training loss, validation loss, training accuracy, validation accuracy.
Loss and accuracy. Lower loss, higher accuracy is good.
Generally, yes. Loss measures how wrong the model's predictions were. Accuracy measures how often it was right. You want loss to go down and accuracy to go up, both the training data and the validation data.
The validation data is key.
It really is. Because if your training loss keeps dropping but your validation loss starts going up, that's a sign of overfitting.
Meaning it learned the training examples too well, but can't generalize.
Exactly. It memorized instead of learned. The portal also shows plots of these metrics, which makes it easier to visualize and spot overfitting. Adjusting those hyperparameters we mentioned can help control this.
Makes sense. So you've got your shiny, fine-tuned model. How do you use it?
You deploy it. You can then access it through the Azure AI Playground to test it out, or use the REST API to integrate it into your own apps or workflows.
And you mentioned using the same system message.
Crucial for chat models, yeah.
Yeah.
Use the same system message during inference when you're actually using the model as you use during training. It helps maintain the persona or behavior you trained it for.
Got it. And if you want to improve it later, that continuous fine-tuning.
Yep. You just start a new fine-tuning job, but instead of picking a base model, you select your previously fine-tuned model as the starting point, and maybe add a suffix to the name to keep track of versions.
Smart. Finally, clean up. What if you're done experimenting?
Good practice to delete things you're not using. You can delete the deployments, the fine-tuned model files themselves, and the training data files you uploaded, all through the portal. Keeps things tidy and manages costs.
Okay, Azure sounds pretty comprehensive. What about other approaches? I think you mentioned a YouTube tutorial using the OpenAI API directly.
Right, yeah. Different platform, but similar core concepts. That tutorial also stressed using the JSON format.
What was their example? Making it generate avatars?
No, actually, they used a fun example. Fine-tuning a model to be sarcastic.
Ha! Yep.
Yeah, feeding it examples of questions and appropriately snarky answers. They made a point that you might only need about 10 examples to get started, which is interesting.
Down 10. Wow.
Yeah, for simple tasks, maybe.
Yeah.
They picked a base model, GPT 3.5 Turbo, uploaded the JSON, added a suffix. The main takeaway there was that fine-tuning really shines when basic prompting, just telling the model how to format output, isn't quite enough to get the specific style or behavior you need.
Like sarcasm. Or maybe a very specific artistic style for an avatar.
Exactly. And then there was that Reddit thread you found mentioning a more DIY open source rail.
Yeah, what was the gist there?
Well, interestingly, they also recommended the OpenAI chat JSON format for data prep, just for compatibility, which is telling.
Seems like a standard now.
Pretty much. They suggested using Hugging Face for managing the data sets and models, versioning, sharing, that kind of thing.
Hugging Face is huge in the AI community.
It is. And for monitoring the training process, They recommended a tool called WandB Weights and Biases. Lots of people use it to track experiments.
Okay. Any other key points from that thread?
They touched on LoRa again, suggesting that LoRa fine-tuning can often be practically as good as tuning the entire model, especially if you set it up right. Saves a lot of compute.
So whether it's Azure direct API use or open source tools, the fundamentals seem consistent. Structured data in JSON, maybe using LoRa for efficiency.
That's a good summary, yeah.
Okay, let's bring it back to our main focus, avatars. Creating those digital personas, maybe for games, VR, or just online profiles. How does all this fine-tuning apply specifically there?
This is where it gets really exciting, especially with models like GPT-4o that are multimodal. They understand images and text.
Right, and the vision capabilities.
Exactly. OpenAI bringing fine-tuning to GPT-4o for vision tasks is a potential game changer for things like avatar generation.
How so? What could you fine-tune it to do better for avatars?
Well, think about it. You could fine-tune it for image classification, getting it really good at recognizing specific avatar styles. Is this cyberpunk? Is it anime? Is it photorealistic?
Okay, style recognition.
Or object detection, improving its ability to identify specific features like certain types of clothing, accessories, maybe even specific facial expressions or hairstyles within an avatar image.
So it could learn to focus on the details you care about.
Precisely. Or even image captioning, fine-tuning it to generate much more accurate and detailed text descriptions of avatars, which you could then maybe use to generate variations or feed into other systems.
Imagine training it on like thousands of different fantasy armor sets to generate avatars with really authentic gear.
That's exactly the kind of application. The benefits are similar to text fine-tuning, potentially higher quality, more consistent outputs, the ability to train on vast visual data sets, maybe simpler prompts needed afterwards, lower latency.
So if I wanted to fine-tune GPT-4o to be amazing at creating, say, cute chibi-style avatars, what data would I need? Still JSON.
Still JSON, yes. But now your data pairs images with text labels.
Okay.
So a line in your JSON might have the text description like cute chibi wizard avatar with oversized hat and sparkling staff, and then also include the corresponding image.
How do you include the image in JSON?
The Ancord blog, which detailed this, showed you can either provide a URL pointing to the image online,
Probably easier.
or you can embed the image data directly into the JSON string using base64 encoding. A bit more complex, but keeps everything self-contained.
Right. And the training process itself, similar considerations.
Very similar. You'd still need to think about those hyperparameters, learning rate, batch size, number of epochs, and definitely monitor for overfitting using validation data. You don't want a model that only knows how to make the exact chibi wizards in your training set.
You wanted to generalize that cute chibi style.
Exactly.
Is this GPT-4o vision fine-tuning widely available?
According to that Ancord blog post, it launched for paid API users using the GPT-4o 2024-0806 model. They mentioned OpenAI initially offered some free training credits too, which is nice to encourage adoption, with standard pricing kicking in later.
Good to know. Did they have examples of it working?
They highlighted a few use cases, not specifically avatars, but showing the power. Grab using it for traffic sign recognition, Automat for UI element identification in screenshots, CoFrame for improving visual consistency in generated web pages. These show that fine-tuning the vision aspect really works for specialized tasks.
So the potential for hyper-specialized avatar generation is definitely there.
Absolutely.
Okay, so let's wrap this up. For you, the learner listening in, what are the absolute key takeaways about fine-tuning, especially thinking about avatars?
I'd say first, fine-tuning is incredibly powerful for customizing AI. Taking a general model and making it an expert for your specific need, like generating avatars in a unique style.
It goes way beyond prompting.
Way beyond. Second, it's becoming more accessible. Platforms like Azure OpenAI, techniques like LoRa, and community knowledge are making it easier to do.
The good news for creators.
Definitely. Third, your training data is everything. Getting it right, especially in that JSON format, is fundamental to success. Garbage in, garbage out still applies.
Crucial point.
And finally, vision fine-tuning, like with GPT-4o, is opening up really exciting frontiers for visual tasks. Creating highly specific, tailored 3D avatars is a prime example of where this could lead.
Fantastic overview. So we've covered a lot what fine-tuning is, the efficiency tricks like LoRa, tools like Azure, and the real potential for creating next-level avatars using vision models.
Yeah, it's a fascinating area.
It really is. So here's a thought to leave you with. Imagine the level of personalization possible for your digital self or for users of your application when you can easily fine-tune AI to generate avatars reflecting unique styles, specific features, maybe even emotions. What characteristics, what artistic styles would you focus on fine-tuning for your ideal 3D avatar?
Hmm. Interesting question to ponder.
Definitely something to think about. We really encourage you to explore the resources we mentioned if this sparked your interest. See how you might use these ideas.
Yeah, dive in.
And join us next time for another deep dive into generative AI. Thanks for listening.